Like legend.
An operating system is the software that acts as a bridge between the user and the computer hardware. It manages the computer's hardware and software resources and provides services for computer programs. The OS starts running when the computer is turned on and controls overall the operation of the system. The main purpose of an operating system is to make the computer easier and more efficient to use. First, it acts as an extended machine, meaning it hides the complex details of the hardware and presents the simple interface to users and programmers. Second, it acts as a resource manager, meaning it manages and allocates important resources such as the CPU, memory, storage, and input-output devices. By managing program execution and system resources properly, the operating system ensures that multiple programs can run smoothly without interfering with each other. Overall, the OS makes the computer system organized, efficient, and user-friendly.
The functions of an operating system. Have you ever wondered how your computer actually understands what you want it to do? The secret lies in the operating system, or OS. Think of an OS as the ultimate bridge between you, the user, and the computer's physical hardware. It takes all the complex circuitry and turns it into a virtual machine, an environment where you can easily and efficiently run your favorite programs. To do this, the OS has 5 major jobs. Number 1, the process management. Whenever you open an app, it becomes a process. The OS acts like a traffic cop, scheduling which process gets to use the CPU next. It synchronizes tasks so they don't crash into each other, handles deadlocks so programs don't wait forever, and even helps them communicate with one another. The number 2 is the memory management. Your computer has a limited amount of working memory. The OS allocates memory space when a program needs it and frees it up when it's done. It protects apps from interfering with each other's memory, and if you run out of physical RAM, the OS cleverly uses your hard drive as a virtual memory to keep things running. The third one is file system management. Without an OS, your data would just be a massive, unreadable block of information. The OS manages how data is stored, named, and accessed. It tracks file attributes, handles different file types, and executes operations like reading, writing, and deleting, making sure you can find that one specific document exactly when you need it. The fourth one is device management. How does your computer talk to your printer or your wireless mouse? Through device management. The OS uses special software called drivers to translate instructions to your hardware. It also uses buffering to match device speeds and spooling, which queues up tasks like a list of documents waiting to print, so your CPU can move on to other things. And the last one is the protection and security. The OS is your system's bodyguard. It controls exactly who and what can access your resources. Through user authentication and strict access controls, it guards your personal data against malware, unauthorized users, and data theft. So, from managing memory to keeping your files safe, the operating system works silently in the background, making our modern digital lives possible.
Here are the types of operating system. First, batch operating system. A batch operating system is a system that processes large groups of similar jobs together. Users do not interact directly with the computer while the jobs are running. The operator collects similar jobs, puts them in a queue, and the system runs them one by one automatically. The advantages of this OS is that it can handle large and repetitive tasks easily, it reduces idle time and improves system performance. Many jobs can be processed in a continuous sequence, and it is good for payroll, billing, and data processing. While the disadvantage of this OS is that there is no direct interaction between user and system. Debugging is difficult when errors happen. Response time is slow for individual jobs. If one fails, other jobs may be delayed. And the CPU can stay idle during input or output operations. An example of this OS are payroll processing and bank statement operation. Second is the time-sharing operating system. A time-sharing operating system allows many users or tasks to use the computer at the same time. It divides the CPU time into smaller parts called time slices. The system switches quickly between tasks, so each user feels like they're using the computer alone. The advantages of this OS is that each task gets equal CPU time. The CPU is not left idle. It gives fast response to users, and many users can use the system at the same time. Disadvantages of this OS: if the system fails, all users are affected. Security and data privacy can be at risk. Performance may decrease when many users are active, and it is more complex than batch system. Examples of this OS are Unix, IBM VM or CMS, Windows Terminal Services. Third, distributed operating system. A distributed operating system connects many independent computers and makes them work like one system. Each computer has its own CPU and memory, but they communicate through a shared network. The system divides the work among different computers, so tasks are processed faster and more efficiently. The advantages of this OS is if one computer fails, the others can still work. It processes data faster by sharing tasks between computers. It is easy to add new computers to the system, and it reduces delay and improves performance. While the disadvantage of this OS, if the main network fails, the whole system may stop working. It is expensive and complex to build and manage. Security risks may increase because of network communication, and it can be hard to keep data consistent across all computers. Examples of this OS are macOS and Amoeba. Last is the real-time operating system. A real-time operating system is a system that gives a very fast response to inputs. It processes tasks within a fixed and strict time limit called response time. The system gives high priority to important tasks and makes sure they are completed on time. The advantages of this OS, it gives predictable and fast response times. It uses system resources efficiently, it is reliable and less error-prone, and it is suitable for embedded and time-critical systems. While the disadvantage of this OS, it can run only a few tasks at the same time. It is expensive and complex to design. The algorithms are difficult to write, and it has limited features compared to general operating system. Examples of this OS are air traffic control systems and medical imaging system.
Tatalakay natin isa-isa ang bawat era ng operating system. According to ibconline.com, alam niyo ba na ang mga computers doon ay talagang walang operating systems? Ang unang era ay ang serial processing. Around late 1940s up to mid-1950s, manual pa or pagod kamay talaga ang pag-program at pag-debug. At kung magkamali ka man kahit isang beses, ay kailangan talagang ulitin lahat sa umpisa. Bago pa man dumating ang keyboards na ginagamit natin in today's era, noon ay dagdag hassle pa kasi need dumaan sa punching cards katulad ng IBMs o International Business Machines. Ang code kung saan bawat card ay isang line. Compare sa mga codes natin ngayon, para makabuo ng mga, kahit sabihin natin isang code lang noon o isang program, ay kailangan pa ng iilang cards at talagang patong-patong sila. As you can see here, ang card ay binubuo ng mga holes representing numbers, letters, at itong mga ito ay babasahin ng punch card reader, butas to butas. Pag-umpisa rito sa pinaka-left mula taas hanggang baba, and once na mabasa na lahat ng butas, ay mapupunta na yung data sa computer memory, then execute yung code. Ang pangalawang era ay ang simple batch processing. Sa era na ito, pausbong pa lang ang operating systems at napakamahal pa ng mga computer, where very rich or elite individuals pa ang kayang bumili. Pero ang kagandahan nito compare sa naunang era ay kaya na mag-process ng computer through batches, hindi na yung one by one. Kasi compare sa serial processing, mas mataas na ang paggamit ng CPU or Central Processing Unit. Kasi mas may silbi na siya at nababawasan na ang waiting time bawat reading. Ito ay tinatawag na CPU scheduling. However, mabagal pa rin siya pagdating sa pag-process ng input or output devices. Though useful pa rin ang punch cards during that time where the user submits the punch cards then babasahin ng computer operator. Fortunately, mas kaya nang malaman ang errors ng code mo instead of manually checking talaga. Next era ay ang multi-programming. During this time, may operating systems na ang computers and they become smarter. Mas dumali na ang pagproseso ng programs and because of this, marami nang ginagawang CPU kasi pinaprocess niya ang I/O devices ng sunod-sunod. Kumbaga, hindi siya nagpapahinga talaga unless off mo na yung CPU. Also, sa main memory usage, kaya na ang multiple storing of data compare sa previous era where one program at a time. And ang last era ay multitasking or time-sharing system. Compare sa mga naunang era, marami na talaga ang kumikilos due to time-sharing system. Naging madali na talaga ang pag-process ng programs and napakabilis na ang mag-switch ang CPU to process many programs. Ang mga operating systems na napakalaki noon ay kaya na nating mabulsa ngayon katulad ng Windows ng Microsoft, Unix ng Linux, iOS ng Technophones, macOS, iOS, pagdating naman sa Samsung ay Tizen ang tawag sa OS nila, Chrome OS or Wear OS ng Google, and many more. Operating systems came from manually processed to intelligently smoothen the relationship between us users and our devices tulad ng desktop or personal computers, cloud computing, mobile phones, embedded devices, internet services, and so on. Additionally, due to versatility of OS, mas mabibilis na and user-friendly ang mga devices natin, and who knows, baka sa future ay mayroon pang mas bibilis kaysa sa mga na-experiences natin in today's era.
So now, we will discuss about real-world examples. Number 1, Microsoft Windows. Microsoft Windows is one of the most widely used operating systems in the world. It is mainly used in personal computers and laptops. For examples, used in schools, offices, and computer shops. It is common in businesses for accounting systems, payroll, and office work. Most computer games are designed for Windows. Why it's popular? First, it is user-friendly interface, supports many software applications like Microsoft Office, compatible with many hardware devices. The second one is Linux. Linux is an open source operating system. This means it is free to use and modify. For example, used in web servers and large companies. Many government offices use Linux for security and stability. It powers supercomputers and cloud systems. Why it's important? First, it's highly secure, customizable, stable for long-term use. And the third one is macOS. macOS is the operating system developed by Apple for Mac computers. For example, it is commonly used by graphic designers, video editors, and programmers. It is popular in creative industries like media and music production. So why do people choose it? Smooth and clean design, strong security, optimized for Apple hardware. And the fourth one is Android. Android is a mobile operating system mainly used in smartphones, TVs, and tablets. For example, used in Samsung, Xiaomi, Oppo, and other smartphone brands. Power mobile apps like social media, games, and banking apps. Also used in smart TVs and some car systems. Why its wide use? First, it is open source, customizable, large app ecosystem like Google Play Store. These operating systems cater to different needs. Windows dominates PCs and laptops. Linux, power servers, and custom systems. macOS is the go-to for Apple users and creatives, and Android rules the mobile space. Each has its strengths, making them popular in various industries and use cases.
To wrap things up, nakita natin ang operating system ay hindi lang basta software. Ito ang nagsisilbing utak at tulay sa pagitan natin mga users at ng computer hardware. Kung wala ang apat na core functions na ito, ang process management, memory management, file system management, at device management, hindi maging organized at efficient ang pagtakbo ng ating mga gadgets. Dumaan naman tayo sa iba-ibang type of OS na may kanya-kanyang lakas. Mula sa batch systems na pangmaramihang trabaho, time sharing na nagbibigay ng equal attention sa bawat user, distributed systems sa pinagkakaisang maraming computers, hanggang sa real-time OS o RTOS na critical para sa mga bagay na bawal ang delay gaya ng medical systems. Nakaka-inspire din ang naging evolution ng OS. Biruin ninyo mula sa serial processing noong 1940s na kailangan pa ng literal ng pagod kamay sa punch cards at manual debugging, ngayon ay nasa multitasking era na tayo. Yung dating kasing laki ng kwarto ng computer, ngayon ay kasya na sa ating mga bulsa at kaya mag-execute ng complex programs in less than an hour. Kaya naman sa ating real-world examples, kitang-kitang versatility nito. Ang Windows na para sa ating productivity at gaming, Linux para sa security at servers, macOS para sa mga creatives at Android para sa ating mobile lifestyle. Ang bawat era at ang bawat type ng OS ay patunay na habang tumatagal, mas naging smart at user-friendly ang tech natin. Sinang mas nakakaalam kung ano pang mas mabilis na mararanasan natin sa susunod na era, di ba? At dito nagtatapos ang ating diskusyon. Maraming salamat sa panonood.